Hello everybody, I'm Fabrizio Vicari, Innovation Manager of Resources, and today I'm here in Trapani. This is the 31st of July 2024. We are here in Trapani, Sicily at the Resources premises where the SEArcularMINE pilot plant is installed. Today it is running, operating, simulating the effect of variable energy sources as an input for the components of the plant itself. So let's go to have a look. We operate under the project SEArcularMINE, and we do respect the safety of our employees. So we start by feeding the seawater bitter containing those IBCs into the ultrafiltration unit here operated by Giuseppe Scelfo, PhD at the University of Palermo, which is removing the suspended solid by the inlet bitter to recovery carotenoids. After the recovery of carotenoids, we have the extraction of boron operated by the skid, which was designed by the University Polytechnica of Catalunya, the UPC group, our partners in the SEArcularMINE project. This unit recovers boron and germanium as well. After that, in that white tank, you can see the bittern after the extraction of carotenoids and also boron and germanium. So it is ready to be operated within the magnesium controller granulometer crystallizer, which was designed by Resources, and it is now operated by Ferdinando Miciletta, PhD student, probably in the future of UNIPA. And today is actually verifying the behavior of the controller that he has designed to operate automatically the pH control and monitoring of this instrument here, which is recovering solids in the form of suspended particulates that you can see in the tube flowing through those impellers. After the production of the particles, the suspended solid that we call slurry go to this tank, which have a specific shape to accumulate the solids at the bottom, and that is sent to the filter that we will see afterwards, while the clarified solution in the upper part is sent to the second skid for the extraction of the residual divalent cation contained in solution. Also, this skid was designed by UPC in Catalonia, and is this one, which can operate continuously, and it is currently operating continuously with the clarified solution exiting from the thickeners that we have seen outside the plant. So in this moment, the reactor, the thickeners, and the second skid for the removal of the divalent cation are operating continuously. After the extraction of magnesium, calcium, and strontium, the clarified solution exiting from the skid goes to those basins that you see behind me, which collect the salt solution, where the amount of sodium chloride is still very high. This salt solution is mainly composed of sodium and chloride, and we use these two ions to produce, from the one hand, hydrochloric acid into this tank, and on the other hand, sodium hydroxide in these other tanks. These four outlet tanks are fed in a feed and bleed configuration, which operates over electrodialysis with bipolar membrane that you can see there, designed by Suez, our partner in the project, and currently operated by Andrea Curcasi and Calogero Cassari from the University of Palermo. You can see there the control and monitoring station, which is now operating, simulating those fluctuations which are typically of renewable energy sources. There we can see Simona Hassel collecting samples and taking notes of every single parameter exiting from the pumping station of the EDPM, and Marcantonio Nampara, which is finally extracting our white gold, the magnesium hydroxide, which is collected in the drum filter. So the cycle is closed in this room, producing with that stack, the EDPM, the solution which are fed to the magnesium crystallizer and the skid for the extraction of trace elements that you have seen in the room before. But in order to implement a full circularity, we also treat the final saline solution to extract water, because we have a unit which is very noisy, a reverse osmosis unit, which squeeze the final saline solution to produce the permeate water that we have seen there in that tank, and accumulates water which is then fed to the units that need it. And this is the SEArcularMINE project plant, and I hope you can come to visit us as soon as you can.